Listen up, 8th graders. My dad is literally going to make a video for you so that you can literally understand systems of equations. You literally better pay attention so you can literally be at the top of your game for the test week. Peace out.
Alright guys, you heard Andrew, so pay attention. Here we go. A little rundown on systems of equations. Everything you've seen before, nothing new, just review. So here we go. So there's three ways we solve systems of equations. Elimination, substitution, and graphing. So the first way we're going to do it is elimination. So this is, again, a state test question from a year or two ago. It says determine the solution to the system of equations below. Well, if you look at this the way it's set up, the x's won't cancel, the y's won't cancel, so you need to manipulate them a little bit to make one of the variables go away. And if you're paying attention, definitely the x's are easier to get rid of than the y's. Alright, you could get rid of the y's, but it would involve multiplying both the top and the bottom equations by a factor in order for them to eliminate. So I would say, again, getting rid of the x's, what would cancel out a positive 3x? And hopefully you're like, oh, a negative 3x, which is true. Alright, so you could multiply the top by negative 3, and that would give you a new equation of negative 3x plus 3y equals negative 3. Again, you distribute negative 3 to everything on both sides of the equation. Alright, now you're going to combine these. When I say combine, I mean add. Alright, so you're adding those two equations together. Right? Clearly the x's cancel. 3x, take away 3x is 0. It's not just x. They're gone. It's just 0. Now combine the y's. Negative 5y plus 3y is negative 2y. Alright? And 11, take away 3 is 4. Duh. 8. Okay? Divide negative 2, divide negative 2, and without a whole lot of work, y ends up being negative 4. Alright? But we're not done. Right? We've got y, we need to figure out x. So, when you know y, how do you get x? Plug it in, plug it in. Okay, I hear OB saying it right now. She's loving that. Alright, so it doesn't matter which equation, or you should remember that it doesn't matter which equation you use. So I'm going to use, I don't know, the second equation. So 3x minus 5y equals 11. Okay? And since y equals negative 4, where I see a y, I'm replacing it with negative 4. And now I need to solve for x. So negative 5 times negative 4 is a positive 20. Right? And it's just a matter of solving for x. Subtract 20, subtract 20. 20's cancel. Bring down the 3x. 11 take away 20 is negative 9. Divide 3, x equals negative 3. Alright, so you might be like, wait a minute, is it negative 4 or is it negative 3? What's going on? So it's the ordered pair. If you were to graph these two lines, they would cross at the point negative 3, negative 4. Alright, so that's your solution. Okay? Negative 3, negative 4, oops, sorry, in parentheses. Okay, put them in parentheses as an ordered pair. Okay? So that's your solution. Okay? TV malfunction, so I can't help you right now, buddy. I'm done. Okay? I'm recording. I know. When I'm done, I'll fix it. Okay? Okay. Next problem. So that's by elimination. Next one's by, as you can see, substitution. Alright, so substitution takes place when you see y equals or x equals something. In this case, y equals negative x plus 19. So where I see a y, I'm replacing it with negative 8x plus 19. So negative x plus 6. And again, I'm going to replace that y with negative 8x plus 19 equals 16. I'm going to solve for x. Okay, so I'm going to distribute x to the negative 8x and the 19. So I've got negative x. There we go. 6 times negative 8x is negative 48x. Okay. 6 times 19. If you're not sure, off to the side. 19 times 6. That's my wife. That's Mrs. Kilburn. Okay, so 9 times 6 is 54. Carry. Okay, 114. So plus 114 equals 16. Combine like terms, you get negative 49x plus 114 equals 16. Subtract 114 to both sides. My wife's making faces at me, so you can see that. Okay, and I'm just solving for x at this point. Negative 49x. 11 take away 114 would be negative 103. Did I make a mistake here somewhere? I think I did. 5, 19 times 6. That's right. That's right. Oh, this is supposed to be 16 over here. Duh. So that would make this. Sorry, guys. 98. Negative 98. Yep. Oh my gosh, this stupid thing sometimes. Divide by negative 49. Divide by negative 49. And you get x to be 2. Okay, but again, I don't want just x. I need y also. Alright, so let me get rid of a bunch of this stuff here. Come on. Okay, since x equals 2, like I said, now I need to figure out what y is. So, I don't know, probably use that first equation. Y equals negative 8x plus 19. And since x equals 2, where I see an x, I'm going to replace it with 2. Y equals negative 16 plus 19. Y equals 3. So once again, it's not just 2, it's not just 3. It's the ordered pair 2, 3. If you were to graph those two lines, that's where they'd cross. Okay, so there's an elimination, there's a substitution, and now a graphing systems question will probably come in the form of a multiple choice question. It doesn't have to, but a lot of times they do. Okay, so it says line N is drawn. I think that part got cut off. So line N is drawn. Line Q will be graphed on the same grid. The only solution to the system of linear equations by lines N and Q are when x is 3½ or 3 halves and y is 0. Which equation could represent the line? Okay, so they're telling you that the line of line N, the solution to the system, when line N and line Q cross here. So I'm going to replace that 3 halves with 1½ Okay, so they're telling me that the two lines cross at this point. Okay, so I would figure out where that point is. All right, so 1½ 0 is right there. Okay, so the two lines cross there. So I need to figure out, all right, well, which of these lines, choices A, B, C, or D, cross at that point? All right, so the first one, 3 halves x. Well, I would start at 0 and go up 1½ and 1 to the right. Up 1½ 1 to the right. Okay, are they going to cross there? Obviously not. Okay, so then try the next one. 4/3 x minus 2. So I'm going to start at negative 2. And I'm going to go up 4, 3 to the right. 1, 2, 3, 4. 1, 2, 3. Okay, do those cross at that point? Yes, they do. So it's that one. All right, so let's just verify why the other ones don't work. Okay, again. Okay, negative 5/2 x plus 1. Okay, 1, 2, 3, 4, 5, 1, 2. Okay, choice C is not going to work. And then choice D, negative 2/3 x plus 3.5. So start at 1.5, or 3/2 rather. Start at 1.5 here, and go down 2, 3 to the right. 1, 2, 1, 2, 3. Okay, so not quite. I know that line's kind of squiggly, but you get the gist of it. Okay, not quite. All right. So obviously choice B makes sense. That's where they cross. Okay. So because the slopes were different, they did cross at one point, which we talked about today. Okay. Lastly, so that's the systems solving by graphing.